Double replacement reactions. Okay, so this is another example of how Table F can be useful. And that is to show you whether or not a double replacement reaction will indeed occur or not. So double replacement reactions, they occur only when you produce either an insoluble precipitate or you produce a gas. Otherwise, you just have two things in solution and 4 ions floating around together and nothing's happening. So you have to determine whether you're going to form a gas or an insoluble precipitate. Well, Table F will determine whether you determine that insoluble precipitate. So what you have here in this example, we have potassium carbonate, K2CO3, potassium carbonate, and magnesium nitrate. As it stands, potassium carbonate and both potassium carbonate and magnesium nitrate, they are both soluble, okay? They are aqueous solutions. When you mix them together, you need to determine whether there's going to be an insoluble product. So what you do is you mix them together, and you get possible combinations called magnesium carbonate and potassium nitrate. And so this is where you have to look at Table F and say, all right, on Table F, do any of these things form insoluble precipitates? Are they insoluble? Well, I can tell right from the beginning that any group 1 element, all right, with any compound, and then you also throw in the nitrate, those are going to be soluble. So that's not a precipitate there. The other one is magnesium carbonate. Well, magnesium carbonate, when we look on Table F, we see that the carbonates are going to be insoluble, and as it turns out, magnesium carbonate is an insoluble product. So this reaction will occur because magnesium carbonate is an insoluble product that is not dissolvable in water, does not dissolve in water. So therefore, this double replacement reaction will indeed occur. Okay, so let's look at the next one. Lead acetate and ammonium hydroxide. Well, right at the beginning, I can tell anything that has an acetate in it, anything that has an acetate is going to be soluble, so lead acetate is soluble. Anything with ammonium is going to be soluble, so ammonium hydroxide is soluble. If we do indeed have a double replacement reaction, then ammonium would switch partners and become ammonium acetate. So let's write that one. And there's the formula for ammonium acetate. The other product is going to be the combination of lead with hydroxide. So now let's write that one. Now the one thing you have to remember is you have to balance these compounds because and understand the charges. So ammonium is a +1, acetate's a -1. So that's why we're going to get NH4 C2H3O2. Even though on the other side there's 2 C2H3O2s in parentheses. That's because lead is a +2 ion. So when we make the new compound with hydroxide, which is a 1- ion, we're going to have lead 2 hydroxide, which is PbOH2. We now need to look on Table F. Table F says, are we going to have soluble things? Is this going to be soluble? So we look. Well, I know right here because of ammonium, anything with ammonium is going to be soluble. So I'm going to write that one as aqueous. The hydroxides, however, are insoluble. Over here it says hydroxides are insoluble unless they're with group 1s or ammonium, which the first case it was, but now it's with lead. So it's soluble with calcium, barium, strontium, group 1s or ammonium. Lead is not one of those. So therefore, this reaction will form a solid precipitate of lead 2 hydroxide. And so that will be our actual reaction that does occur. In this example, sodium chromate, which is aqueous because anything with sodium, which is a group 1, is going to be aqueous, going to be soluble. With silver nitrate. Nitrates are all soluble, so silver nitrate is soluble. If we do our double replacement reaction, we will get sodium nitrate and silver chromate. So again, we have to look on Table F, see what Table F says. Well, Table F says anything with a group 1, anything with a group 1 is going to be soluble. Excuse me. Anything with a nitrate is going to be soluble. So therefore, this thing here is soluble. That is going to form an aqueous solution. Table F also says that anything that forms a compound with a chromate, chromates are going to be insoluble unless you have a group 1 ammonium, calcium, or magnesium. Well, in this case right here, we have silver chromate. And as it turns out, silver chromate is not one of the things that is soluble. So this is going to form an insoluble product. And so that will be the precipitate. So for the remainder of these on this worksheet, you're going to go through, you're going to write down the 2 possible products, and from them, you will also determine whether or not those products are soluble or insoluble. For those of you that want to challenge yourself a little bit, you can go back and determine whether or not the equations are balanced. And if they are not balanced, you can balance them. So if you look at this equation here, on the reactant side, you notice you have 2 acetates. On the product side, we have 2 hydroxides. All right, so we're going to need coefficients in order to balance that. So I'm going to need 2 acetates. I'm going to put this coefficient there to give me 2 acetates, but that also now makes me have 2 ammoniums and 2 hydroxides on my product side. So putting a coefficient right there of 2 balances my equation. Again, going back and balancing the equations is an extra step. I think it's a valuable step, but I think it's an extra step for those of you that want to challenge yourself a little bit beyond just determining whether or not there will be an insoluble product created.